Hello and welcome to this video on finding the midpoint and the length of a line segment. Sometimes the length of a line segment is called the distance between 2 points. So let's check it out. All right, so our first formula we're going to look at is the midpoint formula. And the midpoint is the point that lies halfway between 2 points. So see these 2 points here? This midpoint is the pair of coordinates that lies halfway between them. So this point. And all it is you're taking the average of the x coordinates and the average of the y coordinates. Can you see that's the average of the x, the average y? Okay, now let's try out a question using this formula. Okay, so find the midpoint of the line segment joining these pairs of points. So 0, 2, and 2, 8. So the first thing you want to do is go to your formula sheet because it should be given on the formula sheet, midpoint of a line segment. Then you are just going to label the points, x1, y1, x2, y2. All right, so let's write our formula. M equals x1 plus x2 divided by 2. y1 plus y2 divided by 2. Now this comma scares people a little bit, but it's okay. We're just going to keep simplifying until we get a single pair of coordinates, okay? So now we're going to substitute into our formula. So x1 plus x2. So x1 is 0, x2 is 2. So substituting, 0 plus 2, divide 2. y1 plus y2, so 8 plus 2, divide 2. And then we're going to simplify each of these coordinates. Easy. All right. So simplifying on the numerator, 0 plus 2 is 2, divide 2, comma, 8 plus 2 is 10, divide 2, 2 divide 2, anything divided by itself is 1, comma, 10 divided 2 is 5. So the midpoint of these 2 points is the coordinates 1, 5. All right. And let's try out this one. All right. Actually, I might have a look here. So let's just quickly find the midpoint here and see if it would make sense. So the midpoint, just to show you on a graph, so I'm going to label my points, x1, y1, x2, y2. All right, now, average x. So we're going to do 2 plus 4 over 2. And then the average y coordinate, 5 plus 3 over 2. Just showing you what it looks like. So 4 plus 2 is 6 over 2. 5 plus 3 is 8 over 2. 6 over 2 is 3, 8 over 2 is 4. So this is our midpoint. 3, 4 lies in between 2, 5 and 4, 3. So see, can you see that? Halfway between 2 and 4 is 3. Halfway between 5 and 3 is 4. Hopefully that makes sense. Now this one has a few negatives in it, so it might just be a little bit different. Let's try it out. M is, well, we've got our formula. I'm just going to paste it over to save a little bit of time. Okay. Now label the points underneath. Okay. x1 plus x2, negative 1 plus 6 over 2. y1 plus y2, 5 plus negative 1 over 2. And you're just simplifying. So negative 1 plus 6 will be 5, crossing into the positives, over 2. 5 plus negative 1, well, that means 5 take 1, which is 4. 4 over 2. 5 over 2 is 2.5. 4 over 2 is 2. That's the midpoint. You want to end up with a pair of coordinates. Okay, let's try this one real quick. Find the midpoint of this line segment. So first, write your formula. Your average x, your average y. Okay, y1 plus y2 over 2. And remember, label your points, x1, y1, x2, y2. And we've got our average x, so -7 plus 1 over 2. y1 plus y2, -16 plus -1 over 2. Now, what have we got? -7 plus 1, just -6. -16 plus -1, getting more negative, -17 over 2. And we just want to end up with a single pair of coordinates for the midpoint, -6 over 2, -3, -17 over 2, -8.5. So this is the midpoint formula. Remember that there's a comma there. There's not a plus sign or anything. And you want to end up with a pair of coordinates. Now, our next formula we're going to look at is this one here, which looks pretty crazy. But again, we've only got these 4 variables. We've got x1, y1, x2, y2. So this distance between 2 points, or length of a line segment formula, is like this, okay? It is actually derived from Pythagoras' theorem, where you're finding the hypotenuse of a right-angled triangle. So if you remember Pythagoras, right, let's do it here. Actually here. C squared equals A squared plus B squared. So finding the hypotenuse, remember the hypotenuse was the longest side? So if I rearrange this formula for C, I get C is the square root of A squared plus B squared. Notice this? L is the square root of something squared plus something else squared. And so if I was to drop a right angled triangle between these 2 points, you would see that actually. Okay. So this distance here is called the change in y. Notice that? Change in y. y2 take y1. And this distance is your change in your x coordinates, which is here. So see how it's similar? These 2 formulas are similar. So you can derive one formula from the other. All right, and let's just start it out. The trick is to just ignore that big square root sign and simplify underneath it. Simplify this bit first, okay? And we're gonna try it out. Let's do it. Find the length of the line segment joining these pairs of points. So starting with this question 1, okay, L equals square root x2 take x1, and this will be on your formula sheet, so make sure you turn straight to that page, y2 take y1 squared. Now, just like with the midpoint formula, you're going to label your points first. The first point, x1, y1. Second point, x2, y2. And then we're just going to carefully substitute into this formula. All right, so x2 is 2. x1, 1 squared plus y2, 6. Take y1, 1. Now we're going to use BIDMAS or BOMDAS, whatever you like to call it, to simplify underneath the square root sign. Now ignore that square root sign for now. BIDMAS. Okay, so it's saying if there is any brackets, simplify within them. That's that B. So let's simplify within the brackets first, okay? So we've got a pair of brackets here and here, and we can do that at the same time. So 2 take 1 is 1. So we've got 1 squared. Just going to keep it in brackets because it can get a little bit tricky and easily make mistakes. So 6 take 1, 5. So we used our brackets. There's no little numbers. Or yes, there is actually. Right here, indices. So now we're going to do the indices. 1 squared is 1, plus 5 squared, so plus 25. And then we have got addition. Can you see that? 1 plus 25 is 26. So just automatically write down that square root sign, and then we'll worry about it at this point. So they might ask you to answer in exact form, or they might ask you to answer correct to 2 decimal places, which is what they have in this question. So I'm just going to quickly put that in, square root 26, and to 2 decimal places. So in my calculator, it's 5.099, and that will be 5.10 in my calculator. Now, let's try another one. Now there's some negative numbers in here, and they can be a bit tricky, but as long as you just follow a process, label your points, x1, y1, x2, y2, and then we've got our formula, which is on our formula sheet. We don't have to remember anything. The change in our x coordinates plus the change in our y coordinates. And then just as a matter of substitution. Careful substitution. x2, take x1, take negative 2 squared plus y2, take y1. And then using BIDMAS to simplify underneath that square root sign. So I'll write BIDMAS down here this time. Okay, so first of all, it says if there's any brackets, simplify within them. So taking away negative 2 is the same as 0 plus 2 squared. So 0 plus 2 is 2. Simplifying within the brackets, and then we'll worry. So negative 4 takes 0, negative 4 squared. You must include those brackets, because if you do in your calculator negative 4 squared, it's actually going to give you a negative number, whereas negative 4 squared will give you a positive number. So just be careful. All right. Okay, now we've done our simplified inside the brackets. Now indices, the little numbers. So 2 squared is 4, plus in brackets negative 4 squared, 16, square root 20. And to 2 decimal places, like they ask in the question, 4.472, so 4.47 is our answer. And last question of the day, and then I'll just show you a little summary, finding the length of this one. So first, go to your formula sheet and know that this is the length of a line segment or the distance between two points. So you change in your x values squared plus change in your y values squared. Now we've got 4 variables here. Let's label our points. First point, x1, y1. Second point, x2, y2. Oops. Substitute. x2, take x1. 3, take negative 3 squared plus negative 1, take negative 4. Negative 1, take negative 4 squared. Now when it's like that, you can simplify it a little bit. So that's the same as saying 3 plus 3. And that's the same as saying negative 1 plus 4. So let's do it. BIDMAS. Simplifying underneath that square root sign. 3 plus 3 is 6. So simplifying inside the brackets, sorry. So 6 squared plus negative 1 plus 4 will give me, in the positives, 3 squared. Indices now. Forgetting about the big square root sign for now. 6 squared is 36 plus 9. Oops. 36 plus 9. Oops. Sorry. Square root 45. Now we worry about the square root sign at the very end. We want to answer correct to 2 decimal places. Square root 45. 6.708, so 6.71 is our answer. That's the distance between those 2 points. Final slide, tips to find the midpoint or length. So just always label your points underneath. Straight away, x1, y1, x2, y2. Your midpoint formula, you want your answer to be a pair of coordinates. So remember that there's a comma here and simplify line by line. And your distance formula, simplify underneath the square root sign using BIDMAS to guide you. So just forget about the square root sign till the very end and be careful of squaring negative numbers. Put brackets around the number you're squaring. Because if you do this in your calculator, it's going to get a different answer to this. They are not equal. And that's all I have for you. So you have a lovely day or night, all right? I'll talk to you soon.